my name is Chris. Don't try the whole thing. I'm very grateful for Christian's introduction because, in fact, I'm going to talk about something which seems like it's distroless, but it's not really about removing any distro, so I'll talk a bit more about that in a while. I am with Canonical. I've been doing cloud and edge computing for quite a while, and in that time, I started working with containers, and at Canonical, my team and I, we work on the processes and practices of building containers, a new generation of Ubuntu-based containers at Canonical that we call Rocks. And we support the tools that help us build those containers. Rockcraft, for which you will have a workshop just after this talk. And the other one is Chisel, which is the topic of this talk, right? So again, we are not going to talk about creating distroless containers. It's more about how do you think about using that concept to create something which is still Ubuntu-like, but just a slice of it. That's what the tool Chisel is here for. Now, if you are new to the container space, I just want to give you a very brief introduction to what it is, and it's just yet another virtualization technology. Now, the point here is that you want to isolate your application in a software unit that contains all the dependencies for your process to run. And some of you might be thinking, oh, that's very much like a VM. Sure, the difference here is that with containers, we are not virtualizing the whole operating system. We are not using hypervisors. With these containers, we are basically making use of Linux namespaces and C groups to find this compartmentalized space where you can run your process. Now, containers have been around for quite a while, and with the popularization of the technologies and the tools around it, they have become quite accessible for people to build their own images and run their own containers. So the practice was so accessible that people were just, OK, I'm just going to start from a base. I'm going to add my application. I'm going to add some build tools to build my software, the dependencies, and then I'll just snapshot everything into an image, and that's it, right? The problem here is that that was the practice, and it still is in some cases. I'm not saying it was the best practice, because you would end up with very, very, very chunky images that would affect your network performance when you have to pull that image to deploy and to pull the forthcoming updates. And if that's not a problem for you, because you might say, I have a very fast network connection, I don't pay for network per the byte, you might also consider the attack surface, right? The more things you have in your container, when you have deployed it, the more things you will have for attackers to exploit, right? You might have stuff in your container, utilities that you have used during the build, stuff that was there from the base that you have used that you don't need for your application to run, but that others might exploit at runtime. So you want to avoid that. Now, with that came the concept of distroless. And not to kind of re-say what Christian said before, the concept itself is quite neat, right? And that's a practice that we want to follow, but we don't want to remove the distro from it. But the concept itself is saying that you want to pack just your application and its runtime dependencies. And runtime is the key here. You don't want the build time dependencies, right? If I'm going to run, I don't know, if I'm going to run some compiled application, I don't need the whole SDK inside it when I deploy it, right? I've built it, I have my executables, I have my binaries, I'll pack that, and only whatever other libraries and dependencies I might need at runtime, nothing else. So that's what we want to do here, and that will help us achieve this secure and minimalistic container image. The question is, why doesn't everybody do this? Why? If we are talking here about Chisel and distroless and secure container images, why is it that nobody or everybody is still kind of fighting between fully bloated, chunky images versus distroless? So the thing is that doing very minimal and super secure distroless-like container images is kind of still a specialized practice. It is not as easy as just building something from a base and just adding all of your software components in your application. Sometimes it might require specialized tooling. You might need some deep distro knowledge. And in many cases, the mindset is that you would start from that base, do your usual process of getting to your application and dependencies packed in a certain stage in an image, and then you'd go top-down and trim it down to all the essentials. And that process is sometimes a bit error-prone, because what you are doing is that you are inflating a base to have all of your dependencies and application. And then you are going to cherry pick the things that you need from there. You are going to say, I need my application and those dependencies because I know my domain. I'll need that. And the process of doing this is sometimes very manual. You are not using software like package managers that will help keep your provenance and tracing everything you are keeping in your last stage of the build. So it makes things a bit more complicated in the build process. It makes things also a bit less transparent at runtime. And there's a study here which was quite interesting where they took 6 popular vulnerability scanners, no names, and they scanned 20 of the most popular images in a public registry. Now, apart from misidentifications, false positives, and all that, one of the things that was a bit concerning and that I cared about the most is that at least one of those tools, again, no names, was unable to identify vulnerabilities in at least one container, had more than 16 plus of those unidentified, but all of them had some, right? So all containers had unidentified vulnerabilities up to 16 CVEs. Now, this is what we call false negatives. It's not being able to see things that are there, so it's blind spots. And one of the reasons for this is, in some cases, because those scanners rely on data that is inside the container itself, metadata, information that the package manager has put there for others to read. And if that's not there because of that cherry-picking process that you use to get into your final stage, then those scanners will just fail to identify things because they will use common identifiers to match a certain software component to a known vulnerability. So those false negatives and blind spots, they are usually the culprit behind either intentional or unintentional lack of transparency. And what I mean by this is that I did a very quick exercise here. So I took an image. This was some time ago. It was 2404 from Ubuntu. I think there were a couple of low CVEs there. And let's say that I'm not trying to do this on purpose. I could, or I could do this as a mistake of the cherry-picking process. But I am removing a file, a single file from that system. After doing so, 2 of my scanners came back with 0 CVEs. Same thing for Docker Hub when I uploaded my image. So this is just to say that even though it sounds a bit counterintuitive, scanners do rely on the information you put there. So you can intentionally trick them, or unintentionally, with this cherry-picking process of making a very small distroless image, you might forget to put the right information there. So this is the fallacy of complacent distroless containers, right? You see it working, you have built it, you achieved a very small, tiny image, your attack surface is reduced, and it works. So if it works, you don't fix it. And because you don't see the CVEs, they are not reported, you just assume everything is OK. So that's what we are trying to kind of work around here. So we are trying to make a kind of a shift on the practice here. Instead of going top-down, which is the typical distroless approach, we want to keep the distro. We want to start from the ground up, and we want to create a sliced version of Ubuntu, right? That's what Chisel is here for. This is a standalone tool that you can use anywhere. And what it does is that it goes into the Ubuntu archives, and on the left side, you have your typical list of dependencies. Let's say for an application, I have package A, B, and C. That's what I need for my application to run. But with Chisel, we have identified that, well, sometimes you don't need all of that. So what we can do is that we can, in advance, declare subsets of those packages that we call slices. And slices are declaratively defined in YAML files that we call slice definition files. And you will say, OK, slice A, B, C, they have different contents, because I know that from package A, I might just need certain libraries. From package B, I might just need that binary and some data file from there. So you actually know what your application needs, and you can leave out other things that you know are necessary at runtime. For example, man pages or some other binary that you don't need. It's a utility. You can still define dependencies as you do on any Debian package between slices. So on the right side, when you do something like chisel cut, you are cutting those Debian packages from the Ubuntu archives. This specific example here is just showing you the notation that you would use. So it's the package name, in this case, libc6, underscore is the notation, and what comes after that is the slice name. And because we have dependencies between slices, Chisel will look into that, act as a sort of package manager, but just for slices, and give you, out of that, a brand new Chiselled Ubuntu file system. So if you want a quick analogy, just look at Chisel as being something that installs Debian package slices. apt installs Debian packages, Chisel installs slices of that. So I have a very, very, very simple example here. It's just to illustrate that, let's say that you want to have users in your system, right? What you can do is that, well, you know that you might only need a couple of files from a package that delivers those files, which in this case is base password. It's a well-known package. But you only need a couple of files. That's etc group, etc password, all right? However, that Debian package has 17 files, 2 dependencies, and around 250 kilobytes in size. With Chisel, we can create this slice definitions file, and we define one slice. We call it data here. And you can virtually create any number of slices that you want. But here we call it data, and we are saying, actually, I want 2 paths from that Debian package. I only want etc password, etc group, right? That's what I need for my final file system. And here, just to illustrate what you can do, you can also do mutation scripts in Chisel. That is to sort of try to mimic the post-installation and maintainer scripts that you'd get from a Debian package. So the result, if you do this, is that you would end up with your container, your file system, your Chisel file system in the end, that still has user management capabilities, right? But it only has 2 files and 40 kilobytes inside and no other dependencies whatsoever. So I have a quick demo here just to kind of show a bit how Chisel operates and how you can use it as a standalone tool. So you can run this anywhere. So it's not a container-specific tool. So here I'm just doing Chisel help, standalone. And let's say I want to cut a few slices from Node.js. I will Chisel find for a specific release, in this case 2404, Node. I can see that there are a couple of slices there. I want to get more information about these slices, so I want to see what they have. So I'll just do Chisel info for the same release. I'll paste those slices there. This will give me the slice definitions for those 2, so I can parse these with the YAML parser. And I can see that there's a beans slice with all the Node.js binaries in there, and there's a copyright slice that just has the copyright file. I don't need to specify that. It seems to be already a dependency of beans. So for my installation now, I will just say that I want to cut the Node package, and I just want the binaries in my final rootfs chiseled file system. So I'll put that there, and I will add another slice that I will explain later, but it's a dedicated slice for you to get something special that is now available in Chisel as well that we call the manifest, which is there in the last line, a manifest.wall. I'll show you that later. But you can see that Chisel didn't just take Node. It went through all the dependencies that slice needs, extracted those packages, and the slices that are needed to make those binaries work. So here I'm just going to make sure that I actually have Node.js in my rootfs chiseled Ubuntu, and I'm just going to do a hello world. Let's just assume that for the sake of this demo and this presentation, I want to run a hello world, okay? So it's there, seems to be working just fine. And now to that file that we saw earlier, the manifest.wall. This is a Z standard compressed file, which basically it's a manifest. If you ask for it, Chisel will create a file which has a format that we call JSON wall. It's just a file that has a sorted list of different JSON lines where it specifies at a file level all the paths from all the slices from all the packages that were installed in that chiseled file system. So this is quite useful because it will give you a nice entry point, and due to sorting, it's an optimized way for searching through the manifest that you can use to generate, for example, SBOMs and any other files that could be useful for scanning your Chisel file system later on. So here I can see all the packages and versions that I have just installed. So let's copy this into a container image, right? I want to copy the rootfs with this Docker file into a Scratch base. So I'm just going to do it with Docker now very quickly. I'll create a node with a tag chiseled. I'm going to copy that rootfs there onto Scratch. And I'm going to do a comparison with all the node images that I have on my system. So the chiseled one is 100 megabytes decompressed, more or less. And in comparison with all the other ones, you can see the difference. Those are the official ones that you get from Docker Hub, both LTS, LTS Bullseye, and Alpine. And I'm just going to run it again, the same thing as I did on the previous example with Schut. You can see that I can get the Node.js working there the same way I would. Of course, this image is smaller. It might have less capabilities than the other ones, the counterparts I've compared to, but that's because my use case is the hello world, right? I just want to execute that. I don't need anything else, and that's why the point here is to slice the package down to the absolute essentials that I need for my application. The second example is, why do I need to chisel cut at all? Like, we have another tool that's what you will see in the workshop after this session, which is called Rockcraft. And here we work with declarative recipes, YAML files. I have two examples, one on the left, which is kind of a distroless rock. It starts from bare. There's no base there. It's similar to Scratch. Both YAML files are like that, but you can see, in this case, I'm doing Python 3.11. That's my application. But on the right side, I have a chiseled rock because I am installing just a core slice of Python 3.11. I know that I just want to run a hello world. I don't need all the other fancy modules that come with Python 3.11. I just want the core. And this slice is already defined. So I will build these two rocks with Rockcraft. Again, check our workshop after this for doing this yourself. And from the get-go, I have two rocks, one with 28 megabytes, the other one is less than half of that. And if I try to run them, you'll get the same Python interpreter, the same Python version. And for my use case, again, which is a hello world, you will get the same functionality, right? It's just a core functionality. So why would I want to have an image that, even though was started from scratch, distroless-like, it would have much more than what I need. So I just want to keep things to the essential for my application to run. So that's kind of the summary of what you just saw. Plus, on the left side, I've added another example to showcase what you would do the easy way today, which is not even start from scratch. Start from something like Ubuntu, a proper base, and then install Python in it. This would be a rock, right? And it's 42 megabytes. That's probably the most common type of images that you would find in places like Docker Hub. The middle part there is the example we had on the left in the previous demo. That is the bare base, so it's a sort of distroless-like rock with Python 3.11, 28 megabytes. We saw that. And then finally, the chiseled rock, right, with just a core slice of Python. And again, 13 megabytes. And by comparing it with other counterparts, both distroless and non-distroless in public registries for Python, we saw a 61% plus CV reduction. And because it's so small, and we already do certain things in this YAML recipe, as you can see, we are running with a non-root user, we were able to achieve off-the-shelf compliance with certain standards like CIS and STIG. So that's pretty much it. I would like you to give it a try. And again, feel free to join us just after the break for the workshop. You'll have a chance to play a bit with Rockcraft and also slice a few packages and create a few chiseled rocks. You have the two projects there. They're both open source. And you can also contribute there, especially for Chisel and Chisel slices. We are creating a distro of slices that follows the Ubuntu archive. So for every package, we are creating more and more slices to slice down those packages. So you can help do that. We would welcome you there. And if you have questions, we also have a community space. You can find us on Matrix, or you can find me somewhere, or on LinkedIn as well. So feel free to ping me, all right? And thank you for joining me here. That's all. I think we have 4 minutes or so if you have questions, just feel free to. Otherwise, we can take some time back. All right, I think we're good. Well, thank you very much.